All right, guys. So we are going to review 4.6 notes. So make sure you have those out, and we go over this. Okay. So recall in class on Tuesday, we went over how to set up problems, word problems, using the slope-intercept method. And remember, slope-intercept form is this right here: y equals mx plus b. Y equals mx plus b, right there. So we use y equals mx plus b when in a problem we're given the rate of change, m, and a starting point. And recall how the rate of change, we recognize that by the word per. So the admission for the fair is $5, and the cost per ride is 50 cents. So cost per ride, that 50 cents, that's your m, that's your slope, because that's the rate. And then remember, x is always whatever it's per. So number of rides would be x. Number of rides would be x. And then your starting point is the starting point for how much you're spending at the fair, which is $5. That's the amount that you start with as soon as you enter the fair. That's the starting point for your cost. So it's $5 plus 50 cents per ride. So that's where this comes in over here. Y equals mx plus b. So y equals 0.50x plus 5, where x represents the number of rides and y represents the cost of attending the fair. So then they give you this information. If your parents give you $20, write and solve a linear equation to find out how many rides you can go on. Okay, well, $20, is that the x or is that the y? So if you say that's the y, you're correct, because remember, y represents the amount of money or how much you're going to spend there. So that's your y. So you substitute in 20 for y, which is what they did right here. 20 equals 0.50x plus 5, and then they solve for x, subtracting by 5 on both sides, then dividing by 0.50 on both sides to give you an x equals 30. So 30 rides. And that is how you use the slope-intercept method. Now let's talk about standard form. Standard form. We talked about that at the end of class, but I'm going to do one more of these. So we talked about the tacos and enchiladas example, so I'm going to do number 6. But remember, we do standard form. We use standard form when the problem relates two different objects. So just like we have 2 tacos and 3 enchiladas, and they told us how much those cost, notice how that's 2 different objects, tacos and enchiladas. Okay? So let's look at this next problem down here, number 6. So tickets at a school play cost $4 in advance and $5 at the door. Total ticket sales for an evening production were $440. If no tickets were sold in advance, write and solve a linear equation to find out how many were sold at the door. So, first bit of information. Tickets sold at a school play cost $4 in advance, $5 at the door. You can think of the tickets sold in advance as a different object than the tickets sold at the door. So this fits into the pattern of standard form used when the problem relates to different objects. We have 2 different objects, tickets sold in advance and tickets sold at the door. So let's say we make x the one sold in advance. So x represents the number of tickets sold in advance, and y represents the number of tickets sold at the door. And notice it also told us that the cost of each. So $4 per advance ticket, $5 per ticket at the door. So to get how much, and it also said the total ticket sales for the evening production were $440. So the total is what you would get if you multiplied the price times how many were sold in advance. So the price, which is $4, times how many were sold in advance, plus the price of the tickets at the door times how many were sold at the door equals 440. So that is your model. So remember, the 4 represents the price of the advance tickets. X represents the number of advance tickets. So if you take the price and multiply by how many there were, that would give you the total dollars of advance tickets. The 5Y, the 5 is the price of the tickets at the door, and the Y is the number of tickets sold at the door. So if you multiply the price by how many there were, that gives you the total money generated from the door tickets. And if you add those two together, the total advance plus total money from the door, you get the total from the tickets in general, which was 440. So that's where that model came from. And then they gave us one more individual observation. If no tickets were sold in advance. So they told us what X was. If no tickets were sold in advance, what's X? X is 0. Since remember, X represents the number of tickets sold in advance. So we can substitute in 0 for X, and then now we have an equation here that we can solve for Y. So we plug in 0 for X. 4 times 0 is 0, leaving us with 5Y equals 440. Then we divide both sides by 5, leaving us with Y equals 88. So 88 tickets were sold at the door. Okay, what I'd like you to do is do number 7 now. Try number 7 and pause your video, give it a go, and then once you've given it a go, I'll have an explanation that follows. All right, number 7. If Karen's piggy bank has all dimes and quarters. So Karen's piggy bank has all dimes and quarters. And then the total value of the money in her piggy bank is $11.40. Notice how all these problems so far, 5, 6, and 7, have all talked about value, like the total value of 2 different objects put together. So if Karen has 36 quarters, write and solve a linear equation to find the number of dimes she has. Okay, so remember, standard form. We use standard form. When do we use standard form? When we have 2 different objects. So, Karen's piggy bank. So we have, it says all dimes and quarters. So we can say X can be dimes. X can be dimes, the number of dimes. And Y can be the number of quarters. And then remember, we know in total there's $11.40. There's $11.40 total in her piggy bank. So, and if you remember your money values, dimes have a value of 10 cents and quarters have a value of 25 cents. So you take the value of a dime and multiply it by your number of dimes, and then add that to the value of a quarter times your number of quarters, which this model is actually down here, right here. So value of a dime times number of dimes plus value of a quarter times number of quarters equals your total value, which was $11.40. Make sense? Are we seeing a pattern here? So then they go on to tell us that, oh, we have 36 quarters. So does that give us what X is or Y is? Give us what Y is, because Y represents the number of quarters. So we can substitute in 36 for Y, which is what they did in this first step here. And then they solve for X, just like we did up here. So turns into 0.25 times 36 is 9. The 0.10X still is up front. Subtract 9 from both sides, and then divide by 0.10 to get X equals 24. So that means X, which is the number of dimes, is 24. Okay, so moving on to the next type of problem. Remember, this key is available to you on campus. It's in the guided notes key. Okay, so next problem type. Using point slope form. Remember, point slope form is y minus y sub 1 equals m times x minus x sub 1. This right here. Y minus y sub 1 y minus y sub 1 equals m times x minus x sub 1, where those are your y and x, just like in y equals mx plus b. But y1 and x1, those come from a point, a coordinate, x1 comma y1. So that y1 and that x1 come from a point, x1 comma y1. And m still represents the same thing it did up here, which is the slope, the rate of change. So it makes sense that we use point slope form when the problem gives us a sample point, x1 comma y1, and a rate of change, m. So let's see if we can look at this example problem and decide what's a sample point and what's the rate of change. And remember, how do we find a rate of change again? How do we identify one? It usually has the word per built into it. Oftentimes dollars per hour, or a store sells 30 rolls per hour, something like that. So something per something, that's a rate. All right, so at Eagle Bay, it costs $10 per hour to rent a canoe. Nick and his friends rented a canoe for 3 hours and paid $45. Write and solve a linear equation to find the cost to rent the canoe for 8 hours. Okay, so notice it costs $10 per hour to rent the canoe. What is that right there? What does that represent? Well, it's per something, so we know it's a rate of change. It's a rate. So our rate here is $10 per hour. So we have our M is 10. And then notice we have a point. Remember, the X is always the hours. So X is always whatever's at the end of your rate. So $10 per hour. So your X is represented by hours. That's always true with these problems. When you have a slope, whatever comes at the end of the per, that's what X needs to represent. So notice how X comma Y, X has to be the number of hours. So notice, did they give us that? Nick and his friends rented a canoe for 3 hours and paid $45. That is your X, that is your Y. That is the point that they give us. Okay, so we have a slope and we have a point, a sample point. So we can use point slope form, which remember is y minus y sub 1 equals m times x minus x sub 1. And we can go from there. So we substitute in our point, y minus 45, that's your y1, equals 10, which is your slope, times x minus 3, which is your x1. Then remember, the first step to convert this into slope-intercept form is to distribute your 10, turning that 10x minus 3 into 10x minus 30, and then you would add 45 to both sides, which would turn our final equation into y equals 10x plus 15. And just because it's in this form doesn't mean the x still doesn't represent hours, and the y is going to represent, remember, the cost to rent the canoe. So now it said write and solve a linear equation to find the cost to rent the canoe for 8 hours. So there's our linear equation right there. And now we need to find the cost to rent the canoe for 8 hours. Remember, is that giving us the x or the y? That's giving us the x, which is 8 hours. So we substitute in for x with 8. Y equals 80 plus 15. Boom. Y equals $95 to rent the canoe for 8 hours. Okay? So, give number 10 a try. Pause your video, and then I'm going to go over it in a moment. So pause your video until you give number 10 a try, and then I'll review it. Okay, number 10. So we have a construction company charges $15 per hour for debris removal, plus a one-time fee for the use of the trash dumpster. The total fee for 9 hours was $195. Write and solve a linear equation to find the one-time fee for the trash dumpster. Okay, so $15 per hour. Notice the per. That means this is our rate. And the X in this problem is going to be represented by the number of hours. Probably the number of hours that we rent or that the debris removal is going on for. So then it says the total fee for 9 hours is $195. Notice how we have both the X and the Y there. That is an XY pair. So we have the rate is 15, and our XY pair, our XY sample, our sample point is 9, 195. Because remember, you write X first, Y second. So now we can set up our point slope form, which remember, point slope form, Y minus Y sub 1 equals M times X minus X sub 1. So we replace Y minus Y1 equals M times X minus X1. So there's our Y1, replace it with 195. There's our M, came from 15, and then X minus X1, that's our 9. Then to convert this into slope-intercept form, we distribute the 15 in, turning that right side into 15x minus 135. Then you're going to add 195 to both sides. So notice, y equals 15x plus 60. That's our model. So if they ask us to find the one-time trash fee, basically that's another way of asking, how much would it cost if we actually did 0 hours of service, if we just paid the fee? So we plug in 0 for x, so that means 0 hours, and then we solve for what y would be. So it ends up being $60 right there. Okay, so that concludes the lesson for today. Good luck, and good luck with the rest of your cyber work.